All right, we're going to go a little bit more into regression metrics. But before we get started, hit the like button, subscribe, and share with anyone you know taking the AWS Machine Learning Associate exam. So, evaluation metrics. These must match your model type. Classification tasks use accuracy, precision, recall, F1 score, and AUC. Regression tasks, predicting continuous numerical values like price, temperature, or revenue, require different metrics, excuse me. RMSE, root mean squared error, MAE, mean absolute error, and R squared or coefficient of determination, right? These are the ones we're going to go over. So understanding RMSE. Okay. Let's see. Is that here? No, it's not. Okay. So RMSE measures the square root of the average squared difference between predicted and actual values. The formula penalizes large errors more heavily than small ones because squaring amplifies the effect of outliers. Use RMSE when large errors are particularly problematic. Forecasting applications, energy use predictions, or price estimation where being off by $100 is worse than being off by $10. RMSE shares units with your target variable, making it interpretable. An RMSE of $15 means predictions are off by approximately $15 on average, with emphasis on larger deviations. The ideal RMSE is 0, though this is rarely achievable in practice. Lower RMSE indicates better model performance. So, next one is understanding MAE. So, MAE measures the average absolute difference between predictions and true values. Unlike RMSE, MAE treats all errors equally without emphasizing outliers. A prediction off by 10 units contributes exactly 10 to the metric, whether it's the only error or one of many. Use MAE when all deviations are considered equally important, regardless of magnitude. This robustness to outliers makes MAE valuable when your data contains anomalies that shouldn't disproportionately influence model evaluation. Like RMSE, MAE shares units with target values and aims for 0 as the ideal. And understanding R squared. So, R squared describes how well your regression line approximates real data points. The formula compares the sum of squared residuals to the total sum of squares. Values near 1.0 indicate a perfect fit where the model explains all variance in the data. Values near 0 mean the model explains none of the variance. You do just as well predicting the mean for all samples. So R squared can actually be negative when your model performs worse than simply using the mean as every prediction. This happens when severely misspecified models or when overfitting on training data leads to terrible test set performance. Use R squared to compare models and assess how much variance they explain. Unlike RMSE and MAE, R squared is dimensionless and bounded, making cross-problem comparisons more intuitive. So, choosing the right metric. RMSE is sensitive to outliers, but hard to interpret at a glance. MAE is robust to outliers and easy to interpret, but may hide larger systemic errors. R squared is easy to interpret and bounded, but doesn't indicate error magnitude in original units. Choose based on your problem characteristics. If outliers are legitimate and concerning, use RMSE. If outliers are noise, use MAE. For model comparison and variance explanation, use R squared. So how does this work with AWS? So SageMaker built-in algorithms automatically calculate these metrics for regression tasks. Autopilot uses RMSE or R squared to select the best model during automated machine learning. SageMaker Studio displays metrics in experiments and Model Monitor interfaces. Model Monitor tracks regression metrics over time to detect model drift based on prediction error distributions. Amazon Forecast uses RMSE and MAPE, mean absolute percentage error, by default for time series predictions. So, how much does this cost? So, calculating regression metrics themselves cost nothing. They're just arithmetic on predictions. However, the infrastructure supporting model training and evaluation incurs charges. SageMaker training jobs bill per second based on the instance type. Studio charges pay per use for running compute kernels. Autopilot bills based on total training time across all candidate models. Experiments and logging add minimal cost as part of standard SageMaker services. So the free tier includes 250 hours per month of ML.T medium or ML.T3 medium instances for the first 2 months. It's sufficient for learning and experimentation. Once you move to production, this is going to start to cost. Okay, for the exam. When questions ask about evaluating numerical predictions, comparing regression model performance, or choosing metrics sensitive or robust to outliers, understanding RMSE, MAE, and R squared will guide you to the correct answer. Anyways, thank you for joining. Before you go, hit the like button, subscribe, or share this with anyone you know taking the AWS Machine Learning Associate exam. Thank you, and have a good day.